Today's talk is called Blockchain Technology, Trust and the Future of Business. And we're going to be doing a bit of an exploration around what blockchains are and kind of how they're useful to businesses. And to talk about one of the most important questions is, does your business actually need a blockchain? Because there's currently a lot of hype around this subject, so we're going to try and sort of demystify some of the hype. So a little bit about me. So I'm now independent. I'm an independent trainer and book author. I've been working with Pluralsight now for 4 years. It's actually 4 years this week, which is great. And I'm also a consultant for a company in the UK called Block3, where we go into companies and we help talk to the companies about their blockchain needs, whether they actually need a blockchain. If we think they do, we try and sort of help them through the design process with their development teams. So as I said, I've been authoring for 4 years now with Pluralsight. I've got 13 published courses, and number 14 is about 2/3 completed, so that should be out soon. I'm regularly traveling around the world. So I'm an international speaker, so you can see me at events like NDC and Techorama and various other events around the world, and as well as doing classroom-based training. The course screenshot that you can see on the screen now is actually my latest course. It's called Blockchain Principles Practices. So for anyone who is a current subscriber for Pluralsight, this course is there, and it's really good for developers and architects because it kind of demystifies a lot of the hype and goes into quite a lot of detail about how the internal data structures and algorithms of a blockchain work. So it really helps developers understand exactly what it is that they're dealing with. Okay, so a little bit of an agenda, some of the things we're going to talk about today. So we're going to talk a bit about trust and why trust is important, especially on the internet. We'll talk a little bit about what Bitcoin is and then what blockchain is as well. We're going to spend a bit of time talking about how blockchains differ from a database. We'll go through a few example use cases of where some businesses are actually using blockchains effectively. We'll talk a bit about the difference between public and private blockchains and what that means to your business. And then I'll give you a few tips and pointers. So if you are a developer yourself looking to get into blockchain, or you're a business manager looking to maybe do some exploration around blockchain, I'll give you some ideas about some of the tools and technologies that are quite handy for you to look at. Okay, so first of all, I want to talk a bit about trust. Now, the internet is kind of one of those strange environments where it's very difficult to have trust between two parties. And a lot of business models around the internet these days are based around central authorities. So you become a customer of a business, then that business effectively owns you as a customer, and they own your data and kind of any transaction history that goes on. So at that point, it's as you as a consumer, you're putting a lot of trust into that one central authority. And a good way of talking about this, or a very good example, is banks. So everyone, has a bank account hopefully, and uses a bank account. You go to work every month, your salary gets paid into the bank, and then once that salary appears, you then use it to pay your bills, pay for holidays and do all the things that we like to do. But we put a lot of trust in those banks, and sometimes things do go wrong. So over the years, we have seen global recession that's hit us. Everyone probably remembers the big recession in 2008, which is largely essentially down to how banks handled a lot of our money. But also around to how banks handle some of the technology as well. So I'm not going to name the bank, but there was a particular bank in the UK which had a deployment issue a number of years ago, and I was personally affected by this. And because of this deployment issue, it meant as customers we lost a lot of our transactional history for about 2 weeks, which meant it was very difficult for people to be able to pay their bills because the bank at that particular time didn't know what transactions had happened against your account. So that took a few weeks to sort out, and it really did kind of affect the trust that we had in that bank, and me personally, because I was personally affected by this problem. Now, one of the kind of the remedies that we think about to traditional banking are cryptocurrencies, and there's various different cryptocurrencies out there, Bitcoin being probably the most popular, the most famous one. And the idea around Bitcoin is that it's a currency that's completely digital, so there's no printed money, there's nobody responsible for printing money in mints. And the idea is it's completely decentralized, so no one person or authority or company owns Bitcoin. So we have lots of people on a network who are Bitcoin miners, They each have a copy of the transaction history, and then when blocks are created and added onto the blockchain to validate our transactions, everyone on the network has to come to consensus over those transactions. So it becomes virtually impossible to defraud the system, which is one of the main benefits of a cryptocurrency and how it gives us trust. So as I just mentioned, the way cryptocurrencies work is you have a huge network of miners. All of the transactions, so if I pay someone £50 or $50, or they pay me $50, those transactions get sent out to all of the nodes on the network. They go through this process called mining, where they're trying to solve some complex mathematical puzzles. And the first one to create that mined block kind of puts their hand out and says, hey, I've got the block. They send it to everyone. Everyone validates it. And if everyone agrees that that's a valid mined block, it gets added to the network and sent around to everyone. So that's kind of how we get trust through cryptocurrencies. Now, things like Bitcoin and Ethereum and Litecoin and the other, hundreds of different types of coins that are out there, they're commonly used as trading commodities. You get people buying and selling cryptocurrencies like you would do with a normal currency, a fiat currency. But they have practical uses as well. So you can actually use cryptocurrencies to purchase items. So we have a picture on the screen here, which is a Bitcoin-enabled vending machine where you can actually go and buy a packet of chips or a chocolate bar. You provide it your Bitcoin wallet, and then it debits that amount from your account. But a lot of websites are now offering Bitcoin as a valid payment, both for valid websites and for some of the more dark and nefarious websites on the darknet. But it is becoming kind of a valid way that people can transact on the internet. So a little bit of background around kind of where the blockchain concept comes from. Comes back to in 2009, there was a person or persons, because we don't actually know who this person is, but they go by their name as Satoshi Nakamoto. Now, Satoshi, I could say whether it was a person or many people, we don't know, but they wrote a paper on Bitcoin.org, which kind of talks about this new revolutionary way of handling currencies and how, new money can be added to the network and how we have a mining network of different people all trying to get consensus to bring trust into the platform. This is kind of, there have been attempts at doing electronic currencies before, but Bitcoin was the one that really kind of sort of stuck and sort of really gelled with people. But there's more to blockchains than just currencies, and that's kind of where my personal interest in this lies. It's quite common that people trade these currencies. I've bought and sold various different cryptocurrencies myself. But for me as an architect or a developer and a business owner, it's kind of the potential of blockchain and what it can offer businesses that really interests me. So what I want to do is I want to go sort of take a step back and look at some definitions of what blockchains are. So the first one we have here is by the authors Don and Alex Tapscott, who wrote a fantastic book called Blockchain Revolution. So if you're looking for some good resources, this is a very good book to buy. It's a very interesting book. But their definition of a blockchain is, the blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything of value. Now, another definition I really like, which is actually from Wikipedia, but it's a really good definition, is a blockchain is a continuously growing list of records called blocks, which are linked and secured using cryptography. So from this, we can highlight various key important passages. So the first one we have here is as digital ledger. So we know that a blockchain is a ledger of transactions, much like an accounting system. It's a continuously growing list of records. So we know that, the name blockchain kind of describes what it is. It's a chain of blocks that's getting ever bigger. A blockchain should be incorruptible. So once we write data into a blockchain, we shouldn't be able to modify it from that point onwards. So it becomes immutable, it's permanent. And it's linked and secured using cryptography. So the cryptographic techniques of hashing are very important, as well as digital signatures. And they're what we use to kind of protect the chain of blocks as they grow. So we have an incorruptible digital ledger of continuously growing list of records, which is linked and secured using cryptography. If we try and sort of distill that down to a diagram, at the top here we have the notion of a block. Now, a block can contain many transactions. So if we're thinking about an accounting system, those, the first transaction might be payer A sends £50 to payer B. The next transaction could be payer C sends £120 to payer D, and so on. So each transaction represents a specific event that happens in time, which is why it's very good for transactional processing. Then those transactions all get put together into a block, and then they go through the mining process, where the miners on the network are trying to solve a complex mathematical puzzle. This is why things like Bitcoin are so expensive with electricity, because these puzzles take a lot of computing power to solve, and therefore takes a lot of electricity. Because there's a cost associated to that for the miner, they have to be rewarded in some way, which is why we have new currency continuously being added into the network every time a new block gets created, because people want to be compensated for their efforts. This is where the supply and demand aspect of cryptocurrencies comes from. So once that block has been mined, you can see we've got the orange padlock here, which indicates that it's been mined and secured. They then get added into a block. So we have the first block on the left here, has a direct reference to the second block, which has a direct reference to the third block, and so on. And all of those blocks in that chain are linked together using cryptographic hashing. So what this means is if anyone tries to corrupt any of the data in the first block, nodes try and validate the entire chain. Because they've modified some data in the first block, none of the hashes will match, none of the subsequent hashes will match or line up on the blocks, which is how we can detect data corruption or tampering within the blockchain. So if we talk or look back at things like Bitcoin, so currently at the moment with Bitcoin it takes around 10 minutes for each block to be mined. So if we imagine we've got 1,000 blocks in our chain, now Bitcoin actually has a lot more than, it has about, well over 500,000 blocks now. But if we just say 1,000 blocks as an example, that means to recalculate all of the blocks in that chain, it will take 166 hours, which is nearly 7 days. So if you was to go and change or try and defraud one of the transactions in the first block, to make the entire chain validate correctly, you've got to recalculate the hashing puzzles for each of the subsequent blocks. So if you go and change data in block 1, it's going to take you 7 days to basically fix the hashing code for the rest of the blockchain. Now, 1,000 blocks is a trivial example. As I said, Bitcoin now is well over 500,000. So you can imagine how long that's going to take to recalculate. Now, when we talk about blockchains, you'll tend to hear the terms public and private blockchains being discussed. Now, things like Bitcoin and Ethereum are what are known as public blockchains. So this means that literally anyone can write to that blockchain. So if you're a company and you're adding transactions into a public blockchain like Ethereum, you could have people in America, the UK, France, Australia, North Korea, Russia, Spain, or from literally anywhere on the globe can be taking part in creating blocks and validating those blocks. So that might be a consideration for your business. Your data's going up, into this large public network, and anyone is effectively can have access to it and can be mining blocks for it. Now, every node on the network contains a copy of the blockchain, which means every person who's taking part as being a miner has a copy of the entire blockchain on their network. This is part of the kind of the fraud protection mechanism of a blockchain, is that everyone has a copy of it. So you can't just go and change one copy on someone's machine and hope that you've changed the entire blockchain. You need to go and change every single copy on everyone's machine. Now, a public blockchain gives us the best security and trust between peers. It gives us the best security because it has the most people participating on the network. Because it's public, and people who participate in mining are being paid transaction fees every time they discover a block. So for people participating in the public blockchain, it can actually become financially beneficial to them. And because it's financially beneficial, you have more people participating, trying to get a sort of slice of the money, which means the more people participate, the more secure the system is. As I said, the hashing puzzles are time consuming. So currently on Bitcoin, it's about 10 minutes per block to be created. Ethereum is actually a lot quicker. I think it's around 12 seconds, but there is still a latency of having transactions added into the blockchain. Now, quite naturally, some enterprises are very nervous about the concept of public blockchain. So they like the idea of the blockchain, but what they're worried about is actually, having their data going out potentially into the public can be quite scary for a company, especially if you're working in a regulated environment, so financial services, insurance, healthcare. It can be quite a big concern. So this is why we have the concept of a private blockchain. Now, private blockchains can be controversial. So people that are Bitcoin and cryptocurrency purists will argue that there's no such thing as a private blockchain. It shouldn't exist. But the reality is, for businesses that want to explore using this technology, sometimes they'll want to use a more closed network instead of having everyone on the planet participating. This means enterprises favour a more controlled blockchain. Now, what this could mean is that they could still have multiple parties taking part in the mining network, but it might be limited to a consortium of companies. So, for example, let's say you're in a country and you have 20 different banks operating in that country. It's feasible that you could have a consortium of all those banks that are taking part in a blockchain network, mining and contributing blocks to that network. But it's permissions. They have to have permission to be in there, whereas Bitcoin, anyone can take part. So this means it doesn't have the same decentralized security benefits as a public blockchain. So that is a definite advantage of a private blockchain. Is you're not getting the same level of security and trust as what you would do with a public blockchain, but you're also keeping more control over kind of people in the consortium that can have access to that data. This means that the company can then decide who can read and verify those blocks on that network. So if you think about some typical blockchain use cases, I've literally got a handful on the slides here, but the sky is the limit. It's such a new technology, people are still finding new ways in which they can use blockchain. So the first and most common one is digital currencies. That's the one that everyone's familiar with, especially if you've got a Coinbase account and you buy and sell Bitcoin or Litecoin. Another area that's being explored is around voting in the democratic process. So we hear problems in various different countries where they have an election and there's always the allegations about the election being rigged and vote tampering or votes not being counted correctly. So blockchain can actually help solve that problem, because you can have a massive network like Bitcoin network or Ethereum. Everyone registers their vote. We can prove it's been registered once. Once it's been mined into a block, it's kind of in this immutable ledger, which can't be tampered with. So it actually means that we can make the democratic process potentially more accurate. And there's quite a few companies out there that are exploring this at the moment. So another one is as a register for intellectual property. So there's companies out there that are doing systems for, say, registering copyrights or patents or any kind of intellectual property registration, so that if someone tries to lay claim to, say, a piece of music or piece of artwork further down the line, if it's in an immutable blockchain and you registered it first, then you can kind of claim the authority or the ownership of that intellectual property. Some other areas are around financial services, so anti-money laundering and know your customer regulation checks, which are kind of important in a lot of countries and different financial institutions. There are some potential pitfalls around anti-money laundering and know your customer checks, which I'm going to talk about in a moment, but there are companies that are exploring using blockchain as a way of doing sort of fraud checks against their customers. As well as some potential companies looking around the idea of identity management, so using the blockchain as a way of storing their identity. I say there's some potential pitfalls around this, which I'll discuss in a moment. One as well, which is quite popular, is public record registries. So if you think of land title deeds, well, that's what they're called in the UK. I'm not quite sure what other companies call them, but if you buy a piece of land and you want to register the deed that you own that land, there's normally a public registry that information goes to. And blockchains are being explored for doing just that purpose. There's another interesting use case, which I haven't got on the slides, but I just want to mention, which is around tracking supply chains. And an interesting one which I saw was tracking food from its origin through to the supermarket shelves and into your shopping basket. And there's been various different problems in different countries around counterfeit food, or meat that hasn't gone through the correct process, or they've used meat gained from illegal sources. So blockchain is actually being used as a way of tracking food as it goes through different stages of the supply chain. They can sort of put a QR code on the various different packages, and they can actually track what's happening to it. And so, which means if you buy something on the shelf, you could say scan this QR code, and you can then go and check the entire provenance, which is taken from the blockchain, of where that food's been, from origin or the farmer to your plate, which I thought was quite a unique and novel way of using a blockchain. And one of the things I want to bring up, now I know we've got quite a global audience on the webinar today, but one of the things I want to mention is GDPR. So this is the General Data Protection Regulation. It came into effect in May this year in Europe, and it's a replacement of the old data protection laws. The reason why this is important, because even though it's a European legislation, it affects pretty much any company in the globe who might have dealings with European citizens or European companies. So this is a set of laws which everyone has to abide with if you do business with Europe. And in the cloud-enabled internet days that we're in these days, that could be pretty much any company. Now, GDPR at a higher level, there's kind of three core areas. So first of all, the customer owns their data and not the company. So this is very important. So even though a company is effectively acting as custodian of their data, which enables them to do business, it's actually the customer that owns that data, which means the customer can request revisions to that data if it wants, or they have a right to be forgotten and have that data deleted. So as a way of empowering sort of citizens of Europe, this is a fantastic measure for privacy. But it does cause some problems when we're thinking about how we can use a blockchain in our business. So you have to be very careful that you don't put anyone's private or personal data onto a blockchain. So we're talking about data like names, addresses, telephone number, their what sex they are, email address, anything that relates back to a person. Because once that data has gone onto a blockchain like Ethereum, you can't change it. So if a customer says they want to exercise their right to be forgotten and have their data completely deleted, which as a company you're supposed to comply with, you're a bit stuck at that point. How do you remove someone's data from an immutable ledger? So this is something you really need to be aware of and think about quite carefully. And sort of the work I've been doing with Block 3, this is something we discuss at length with customers about, exactly what is it you're going to put into this blockchain implementation. Okay, so now I want to try and help answer the question of, do I actually need a blockchain? Now, blockchain is probably one of the most hyped technologies out there at the moment, and sometimes hype can do quite a lot of damage to a technology. So I've sat in boardrooms for large companies before, and you get the top executives turn around and say, we need a blockchain. It's the current big thing. Investors are investing lots of money into blockchain businesses. We need a blockchain. But really, not every company does need a blockchain. And the thing I try to stress with people is blockchain is a tool. It's a tool like a database is a tool. It's a tool like microservices is a tool. So it has its uses in lots of areas, but there's also areas where it's not really sufficient. So what we do is when we go and talk to companies, we kind of run through a very simple matrix of questions just to try and sort of weed out whether they do actually need a blockchain. And quite a lot of companies that we've spoken to, we kind of go through this process and really, no, they don't need a blockchain. They just need, a distributed, highly available database. Okay, so one of the first things we ask is, do you need a shared public database? Shared and public as in, we're talking about public blockchains. Do you want everyone on the network to have a copy of that data, and do you want it to be out in the public? If the answer to that is no, probably don't need a blockchain. Next one, are there multiple parties involved who need to access and modify and add data into that system? So multiple parties outside of your organization. So if the answer is no, again, blockchain is probably not going to be the solution that you need to look at. So do these parties, so if the answer was yes to that previous one, do these parties have conflicting incentives and or not trusted? So if you're putting data out there into the public and multiple people can, or multiple parties can add data into that system, is there conflicting incentives between those people? If there's not, and there's not a trust issue between those parties, then again, you're probably not going to need a blockchain. It's probably not going to be right for you. can these parties, or are these parties able to play by the same rules? So one of the things with Bitcoin, for example, is you might have, say, 100,000 nodes on the network all mining. Now, each of those mining people mining those blocks have to play by the same rules. So they're all using exactly the same rules for processing blocks, for mining blocks, and validating blocks. That goes for writing data into the blockchain as well. So are all these parties able to play by the same rules? If they're not, and you're not going to get people to work with the same rules, then again, the blockchain might not be right for you. I talked before in the example of having, say, a consortium of banks. It's very easy to say, yes, we'll have a consortium of banks, we'll put them all into this private blockchain network, we'll all agree a set of rules, and then everything will be great. The reality is, if you're trying to get multiple companies, each with conflicting interests and priorities, all trying to play by the same rule set, it's not always going to be the easiest of things to do. So it's something you need to bear in mind when you're going through the thought process. Do you need an immutable log of all the actions to be recorded? So if we think back to essentially what a blockchain is, it's just a big chain of transactions. It's a big immutable log of something that happens in time. So that could be payments from party A to party B. It could be details in the insurance claim settlement. It's a point in time where there's an event. So the blockchain is effectively a record of those things happening in time. It's kind of like a time series log of different events. If that's not what you need, if you don't need that kind of immutable log of time series events, then again, a blockchain probably isn't going to be the right kind of storage technology for you. You're just going to probably need a database. So the transaction rules, do they change frequently? So if they change frequently, the kind of rules in which govern those transactions, or the makeup of those transactions, or even the structure of those transactions, if they change quite frequently, then again, a blockchain is going to be very difficult for you to use, because a blockchain is kind of all about stability and playing by the same rule sets over a period of time. Now, rules do change on blockchains, and there's been several rule set changes in Bitcoin and in Ethereum, but they happen over a very long space of time. They're not quick. So then the final one, then, if we've got through all of those and the answer's been yes to all of those, so we get to number 7. So can transactions be public? So if they can be, then you probably want to go down the path of a public blockchain. If you really don't want them to be public, because you may have some regulatory restrictions which stop you from doing that, then you're probably going to want to go down the side of a private blockchain. So while this is a very simplistic chart, it's kind of a tool that we use when we go into companies, because it's quite simple to run through it. But we would run it as a longer workshop, and we'll get companies to think in a lot of detail about what their answers are. It's very difficult just to answer it yes, no straight away. You kind of need to think about it, but it's a good way of focusing an organisation's mental model about whether a blockchain is actually something that's going to be useful for them, or whether they're just sort of jumping on the latest sort of hype train. Okay, so why use a blockchain over a database? So a blockchain gives you decentralized trust as multiple nodes contain the data and mine the blocks. So we're getting this decentralized trust angle. That's a good reason for using a blockchain over a database. Block creation requires consensus. So if you want to have effectively lots of guardians and watchdogs looking over that data being added into the network, then again, this is what blockchain is really good for. If the data can never be changed once it's been committed, then again, this is what a blockchain is there for. If you need to change that data frequently, then a blockchain isn't going to help you out. The write speed onto a blockchain is not an issue. So if the fact it takes 10 minutes for your transaction to be committed and added onto the chain is not a problem, then that's fine. A good way of thinking of this is a blockchain is kind of more of an eventual consistency model. So you put the data out there to be mined, and then eventually at some point in time, it will end up on your blockchain. So with a blockchain, data integrity is guaranteed, because all of the transactions in that block, along with the creation dates and timestamps, is all hashed together using something like SHA-256 hashing, which gives us good data integrity across the whole chain. So that's a good reason to use a blockchain over a database. But also on things like Ethereum, or blockchains like Ethereum, we have the idea of something called smart contracts. I'll talk a bit more about smart contracts in a few slides' time. But a smart contract is effectively an executable piece of code that you commit into a blockchain instead of a transaction by itself. Now, that bit of code could be taking over the part of a solicitor, for example. So if you're buying a house and you have a solicitor as a mediator in the middle, you could actually use a smart contract as a mediator. Okay, so why use a database over a blockchain? Well, a database, things like SQL Server, MySQL, Oracle, including a lot of the NoSQL databases that are out there, are very fast in comparison. They're fast and very performant. Most database platforms give you very good, highly scalable replication for redundancy. So if really what you want is just to have your data replicated across multiple sites so that the data is safe, the database is probably more what you're looking for because you kind of get that replication model built in. Now, I talked a bit about when you have miners mining on the network, they get compensated for their electricity and computing power that they're using. So someone has to pay that money that gets paid to the miners. Now, part of that comes from new currency being introduced into the network, but part of that also comes from transaction fees. So if you think about Ethereum, for example, when you send some transactions, you have to say what your transaction amount is that you're willing to pay. The higher the amount, the more likely your transaction is going to be committed into the blockchain sooner. So with a blockchain, there is a per transaction cost that you have to think about, whereas with a database, there isn't. It's, once you've got your architecture and set up, the costs are negligible. Now, databases aren't computationally expensive. When you send a write command to a database, it's going to happen virtually instantly. Whereas when you send a write operation for a transaction to a blockchain, it could take, in Bitcoin's example, it could take 10 minutes. And databases generally are a lot easier to manage. So, we have DBAs, we have DevOps engineers. If you all want to understand how databases work, especially like developers and operations people, the databases are they're a lot easier to get up and running. I mentioned about the idea of smart contracts, and for me, this is kind of one of the real killer apps of blockchains. So far, we've talked mostly about just entering transactions. Paul pays Simon £10, Mary pays Sarah £50 or $50. But a smart contract is an executable piece of code. So if we look at Ethereum, it has a language called Solidity built into it. It looks a bit like JavaScript in its syntax, but it allows us to write executable code which runs as part of our network. So it actually turns the Ethereum blockchain into a massively distributed computing platform. And this is where blockchains are really, really interesting, but it's still at its infancy. So I used a very broad example a little while ago about, you've got two people buying a house, and then you have a solicitor in the middle as a trusted third party who kind of mediates between the two. Has person A and person B both signed the contracts? Has, the person buying the house paid the money to the bank? So it's this kind of arbitration that goes on in the middle. So what a smart contract effectively allows you to do is to electronically remove that middleman. So you could have transactions from both of the sellers being written into the blockchain, and then you can have a smart contract looking for those two events to happen. Once they happen, then the deeds for the house could be automatically transferred, and then the money's moved between banks. So as a computing platform and a trust platform, it actually gives us a way of potentially looking at removing middlemen from business processes. Now, depending on where you are in that process or what your company does, that could either be seen as a benefit or it could be seen as a bad thing, depending on what your company does. But this is kind of the exciting thing about smart contracts. I mean, they're quite new, comparably, in computing terms. And this is where a lot of the interesting research and experimentation with smart contracts is going. So I'm just coming up to my last few slides now, but if you're, so I'm not quite sure of the demographic of kind of people on the call today, but if you're a business owner or you're, a business analyst or architect, and you want to get your developers to look at experimenting with blockchains, then kind of a good one to look at is Ethereum. So it allows you to write smart contracts in Solidity. It allows you to experiment locally. So if we download the tools, which you can see on the screen here, so there's a tool set called Truffle, and it says here it's the Ethereum Swiss Army knife, but it's a set of local development tools that's quite well documented, which will allow your developers to start to easily experiment and play around with blockchains without having to, kind of fully commit to the ideas. It's certainly worth all organisations actually experimenting with blockchains to actually determine whether it's suitable for you. And there's a particularly useful tool here, which is part of the Truffle suite, called Ganache. And what this tool does is it effectively runs a single node instance of Ethereum on your local machine. So if you are just wanting to experiment with Ethereum smart contracts, and you don't want to connect to other networks and all that, you just want to do it locally, this is a great one to get your developers to use, because it means they can just work within the confines of their development machine and start experimenting and sort of doing experiments around how blockchains can help your businesses. And then we have tools here like Etherscan. So when you've done a bit of experimenting, you can use a tool like Etherscan, which lets you connect to some of the different Ethereum test networks. So you can see on the screen here, it's connected to a network called Ropsten, which is one of their test networks. So it's not a real blockchain, it's just one of the ones they offer for people to test their solutions with. So that's kind of what I wanted to cover today. The main focus today was to discuss, kind of what is a blockchain, some of the use cases around blockchains, but most importantly, is it right for your organisation? So I hope you found that that kind of matrix useful of questions, and it's a useful exercise you're doing within your companies to try and determine whether this technology is suitable or not for you. So I'm sure if you go back to the recording of this event, you can sort of take some screenshots of those slides and then kind of use that matrix in your own organisation. So I'd like to thank everyone for joining today. Also like to thank Pluralsight for setting up this webinar for me today. If you want to get in contact with me, I am on Twitter, so my address at the bottom of that screen of the page now is @StephenHaunts. So it'd be great to interact with people on Twitter. And also have a website called stephenhaunts.com, where I sort of routinely blog and sort of just discuss things that interest me. So it'd be great to connect with people. So on that, I think we're now going to do some Q&A. So Darian, do you want me to dive into looking at questions?
Yeah, let's jump into some questions. And for the audience, if you have questions from the presentation, now's a great time to throw them in the chat box on your screen. And we have some time to go through those before we wrap up.
Okay, I'll just start looking at the list. So we've got one here. So do you think blockchain technologies will be a passing fad? Which is a very interesting question. So I don't think it's a passing fad, but I do think as a technology platform, it is very hyped at the moment. And hype can be a blessing and a curse. So it's a blessing because it's getting the whole idea of blockchains out there and people are starting to really understand what they are. But also it means that, as some of the boardrooms I've sat in, people immediately think they need a blockchain and it's going to be the solution to all their problems when potentially it's not. So I think blockchains are going to be around for a long time. I don't think they're a passing fad, but I do hope that kind of the overhype and the hyperbole does die down a bit. Another question. Let's expand my window a bit. If it's not a good idea to write personal data to a blockchain, what is a good way to link transactions to a physical person? That's a good question. So if we was to use an example of an insurance claim. So we're wanting to record an insurance claim onto a blockchain so that we know that, Fred Bloggs was paid $5,000 for his car that was written off. So we don't want to put his name or personal details into that transaction, but we can put a claim number or a reference number which ties back to data in say, the claim handling system. So whilst we won't put his actual personal details in the transactional block, what we will put in there is the fact that, an amount of money was paid out to him against that claim. And we put the claim number in there. And then in the actual main database system for that company, you've then got that person's personal information. So if they do want to change their name, maybe they get married and want to change their surname as an example, they then do that on the claim system. But then you still have kind of integrity between the blockchain and that insurance claim. One here, can you recommend conferences to get a developer up to speed on blockchain developments? I can't name any blockchain specific ones off the top of my head, but there are quite a few. one thing that is very good to do is to look on meetup.com for your local area, because you generally tend to get a lot of blockchain meetups these days. So the company I do some consulting with, Block3, and they run in the UK various different events around the country. So local meetups are a really good place to go to because they're not going to cost you anything apart from just travelling to the meetup. A lot of large conferences do have a lot of blockchain talks. I mean, I talk very frequently at the NDC conferences, and there's normally a couple of blockchain talks on there. But obviously, you need to think, are you only interested in the blockchain content, or do you want to see the rest of the content that's at that conference? Because that, potentially could be an expensive option. But I think the best thing to do is to look for local meetup groups in your area. Well, I've got loads of questions coming through. I don't think we're going to get through all of them today, but we've got one here. So who regulates the public blockchain? So the actual transactions that go into the public blockchain, like Bitcoin, for example, nobody regulates it. That's kind of the point. It's an unregulated place, which is supposed to be anonymous. But what we are seeing is a lot of countries are imposing regulations around the identity of people that use certain exchanges. So I'll use, the UK and Coinbase as an example. So I have an account on Coinbase, but for me to set that up, I had to provide a scan of my passport, my driver's license, and other details that they could identify me. Now, as with everything, there's ways around it depending on which network you use. But as a responsible citizen, I wanted to use Coinbase. It's very easy to use. So I was okay to provide that information. So whilst nobody regulates the blockchain as it is, people using various exchanges to trade currencies might have to go through identification checks in their, to conform with their local country's regulations. Got one here. What is the role of the developer in this? So that's a great one. So if you're using something like Ethereum, and you want to, say, enter insurance claim details, which is the example we used previously. The role of the developer in that is to actually create a transaction with those details in. You need to write a smart contract to do that, which means you need a developer to write that code in Solidity, compile it, and then deploy it into the network. As you write transactions into blocks, you're going to have kind of transaction or block IDs, which you might want to store in a local system. So if you want to be able to view data that's in a blockchain but not change, to be able to view it on a portal, for example, then you're going to need developers who are going to be able to make a call into Ethereum, to pull that data back via a HTTP API so you can display it. So it still very much is a role for the developer. I think once you've got your head around how Ethereum works, it's not actually that complicated for a developer to get something going very, very quickly. I think the hardest part for any company is going to be around working out what you want to use blockchain for, if it is indeed relevant. So I think the kind of business conversations are the harder part of it. How do we create a blockchain from scratch? That's kind of a broad question. So it's difficult to answer that without being able to interact with the person who wrote the question. But I mean, if you wanted to have your own version of Ethereum, for example, the source code for all of that is open source. You could do a fork of that code. I mean, Bitcoin has been forked multiple times, which is why you have things like Litecoin. If you're wanting to do more of a digital ledger, so not necessarily a distributed blockchain, but you're kind of interested in the concepts around linking transactions together into an immutable chain. If you go and watch my course on Pluralsight, if you're a subscriber, then what I actually do in that course is, especially for .NET developers, is I walk them through building a blockchain from scratch in C#. Wow, there really is lots of questions. I think we've got time for a few more. How to learn about developing applications using blockchain. There's lots and lots of resources out there on the internet. We also have courses appearing on Pluralsight as well. There's a particularly good one called Blockchain Fundamentals on Pluralsight, which talks about the fundamentals of the technology, but it also walks you through a very simple example of building your first smart contract with Ethereum. So if you want to effectively do the hello world of blockchains, and that's a really good course to get you going. If you use things like Truffle and Ganache, which I pointed to in the slides, they have very good tutorials. And plus there's lots of books. If you go onto Amazon and just search for blockchain, you're going to find lots of books coming out. So I read an article on how much energy is consumed by Bitcoin and blockchain. Should that be a main concern for the future of these technologies? That's a great question. So the current mining process at the moment is called proof of work. So proof of work is where you're having to solve a complex mathematical puzzle, it's a hashing puzzle, to confirm a block. So that is currently very computationally expensive, which is why you see a lot of mining operations appearing in countries like China, because they have cheaper electricity. There is another technique coming out, which I think Ethereum is due to start supporting, if it hasn't already, called proof of stake, which is designed to keep that computational complexity down. I believe the way that works is you're given more weight on the network based on how much of the currency you already own. I believe is roughly how it works, but proof of stake is still quite new, so there are concerns around the amount of electricity it takes, but there are kind of people looking at ways of mitigating that. I like this one. Do you think blockchain has a use in healthcare? So I've spoken to some healthcare companies. Obviously, I can't name them, but one of the things we talked about was when a doctor writes a prescription to a patient. So a prescription, is going to say, I prescribe X and Y drugs to this patient. Take, 5 tablets 3 times a day. Now that information could potentially go on a blockchain. Now you're not going to store the actual patient's personal information on there, but if you want an immutable record to say that we have issued a prescription and then dispensed these drugs to a patient, and you want an immutable proof of that. So if a patient should unfortunately get very ill or pass away from taking medication that's been prescribed to them, if there's any dispute over what drugs were given to them, then if that prescription data is written into a blockchain, then you kind of have immutable proof that you can go back and look at. So that's a good potential use case for healthcare. Can blockchain fight the fake news issue? That's an interesting one. But I think it probably could. But then, I don't know, if you had a consortium of news agencies, or who are supposed to be trusted news agencies, they could post, for like global news stories, they could post those articles into a blockchain, which could potentially stop other fake news outlets who don't have access to that system, potentially. I don't know, that requires a bit more thought, but it kind of feels like there should be a solution for that around there. Again, one of the biggest problems on that is kind of determining what is fake news and what isn't fake news, which I think is probably the harder problem, because one person's real news might be another person's fake news. And you just have to look at some of the conspiracy sites that are out there. Some people believe the stuff that's posted on them, whereas other people think it's rubbish. So I think that would be the harder problem to solve, is actually distinguishing between fake news and genuine news. Got time for just one more question. So I'll do this last one here. So which coding language is best for blockchain in your opinion? So if you're using a system like Ethereum, then you're going to be writing your smart contracts in Solidity, which is their kind of internal programming language. It looks very similar to JavaScript. It's not quite the same, but syntactically it's similar to JavaScript. If you want to interact with the blockchain, so you want to be able to read records out of blocks, read transactions out of blocks, and there's various different ways you can do that. But one popular way of doing it is there's a JavaScript library called web3.js. So if you're writing a web portal, or you've got a Node.js backend, and you want to be able to programmatically access Ethereum, then you do something like web3.js. I believe there are client libraries for Web3 written in other languages. I'm pretty sure I've seen a .NET one that's out there. So you can potentially use your current programming language or system of choice for interacting with the blockchain, but for the actual smart contracts themselves, you're going to be doing that in Solidity. So I'm just about out of time now, so I'd just like to thank everyone for coming along today. It's been good fun teaching you all and talking to you all about blockchain. And so if you are a current subscriber and you want to know more about blockchain in more detail, there's quite a few good courses on there now. So then my one is called Blockchain Principles and Practices. It's more of a technical course aimed at developers and architects, but it kind of talks about how the internal structures and algorithms of blockchain work. So if you really want to understand what's going on behind the scenes, that's a good course for that. Blockchain Fundamentals by Jan Sandberg is a great course as well, because it doesn't go into the areas which my course covers, but it looks more holistically from the outside in about blockchains, and also runs through some interesting examples in Ethereum. There's another course in the library about integrating blockchains or building blockchains using SAP. So if you're in an SAP environment, that could be very interesting for you. And there's going to be many more courses appearing on Pluralsight over sort of the coming months and years. So I think with that, I'd just like to thank you all for attending and thank Pluralsight for setting today up. So thank you, everyone.